Hello everyone, today I want to discuss about the structure of amines. In this, we know that ammonia structure from the chemical bonding, ammonia is a pyramidal shape. But actually, what is the hybridization of this one? sp3 hybridization. sp3 mean what is the actual bond angle? Bond angle will be 109.5 degree or some books 2.8 also given according to one of the textbook 109.5 degree. Then in this ammonia, actual structure, what is that now? Pyramidal shape. This bulkier lone pair, this is which one? This is a bulky lone pair. This bulky lone pair compress these bonds. Now, this bond, and this bond is compressed by this lone pair. Therefore, its bond angle is actually now how much? 107 degree. So it reduced from bond angle reduced from 109.5 degree to 107 degree in ammonia because of lone pair. This is called lone pair bond pair repulsion. This is lone pair. Another one is this is a bond pair. So lone pair bond pair repulsion. Left side also is there and this right side also is there. So therefore due to this repulsion bond angle reduced and it become which one? A pyramidal shape. According to sp3 hybridization tetrahedral including lone pair. So due to that now bond angle reduced, it is a pyramidal shape. This is ammonia related. Now coming to the point of one amine that is called trimethyl amine, a tertiary amine. This is which one? This is a tertiary amine. Here also lone pair bond pair repulsion takes place. Here also hybridization will be sp3 hybridization and lone pair bond pair repulsion takes place here. So in this lone pair bond pair repulsion, compare with ammonia less because these are the CH3 groups are the bulkier group. Therefore here repulsion between this one, so this is called steric repulsion. So due to this steric hindrance, then what happened here? Slightly this bond angle will be open. It means compare with the ammonia here 107 degree, it is little greater because of due to repulsion between this methyl group. So little extra increase. So 109.5 degree to it comes to 107 actually, but due to opening or repulsion between the methyl group, it become 108 degree, little greater in amine when it is bulkier groups are present. So this is about the structure and bond angle. Keep in mind little will be greater bond angle compared with the ammonia. Lone pair bond pair repulsion will be there and extra what is that steric hindrance will be there between the alkyl group or any methyl group. Now, a amine with the three different groups, maybe hydrogen, methyl, ethyl, three different group, three alkyl groups. If it is different groups on the nitrogen atom, then we will consider like the carbon atom with the four different group chiral. Then here also chirality is present or not, we'll discuss. Now around this nitrogen, what are there? Lone pair present and hydrogen present and ethyl group present and methyl group. All these are four different groups present on the nitrogen atom and this lone pair occupied the sp3 hybrid orbital. Keep in mind this is which one? sp3 hybrid orbital occupied by the lone pair. Then this is chiral. Okay, chiral means different is there. but we can separate, or that is called resolvable. In chemistry, that term we can use the resolvable or not. It means we can separate or not this amine. Then the condition is, actually this will undergo inversion. This is called nitrogen inversion. What do you call this? Nitrogen inversion. In this nitrogen inversion, lone pair present in the sp3 hybrid orbital, then it undergo a transition state. So this lone pair present in the p orbital, this is little stable, or we can say this is a fairly stable. This is the lone pair present in the p orbital, and its lone pair is inverted. Again, it become which one? sp3 sp3 hybridal contain lone pair. So it convert from sp3 hybrid orbital lone pair to sp3 hybridal, but configuration is inverted, but through the transition state. Actually, this will become like this. This is the first molecule R configuration. Then it goes to transition state and comes to the S configuration. Then what happened now? This is inverted. But to convert this inversion nearly for this molecule, I hope this is nearly 25 kilojoule per mole energy required. So this interconversion little less energy. That's why easily convert into this one form to another form, therefore resolving somewhat difficult. This is called nitrogen inversion. So keep in mind, in this nitrogen inversion, we have the lone pair present in the p orbital. That's why only we have to consider this bond and this bond and this bond. Therefore, nitrogen having sp2 hybridization. This is very important for competitive exam. So what is the hybridization of nitrogen in the nitrogen inversion at the transition state? That is sp2 hybridization. And one more thing you have to remember, in absolute configuration or in RS nomenclature, the lone pair will get the lowest priority. Lone pair, lowest priority. This is very important in the assigning RS nomenclature. So keep in mind, lone pair always get the lowest priority compared with the other groups. Next, which amines we can resolve? Already I told you that nitrogen with the three different group with the one lone pair, generally it undergo inversion. That's why resolving somewhat difficult. Therefore, which type of amine we can resolve? So chiral amines can be resolved. Then amines whose chirality system from the presence of asymmetric carbon, it means on the nitrogen not chiral, on the carbon should be chirality present. So such one is carbon, here NH2 group, and this is a methyl group. This is called hydrogen, and this is maybe ethyl group, means CH2 CH3. Now the carbon is all different groups contained around the carbon atom, therefore this is called asymmetric carbon. Therefore this can be resolvable. Next, its mirror image. For example, if it is a S2-butanamine, then its mirror image is, we can write like this. This is called ethyl group, CH3, CH2, and next this is a hydrogen, this is a methyl group, this is a NH2 group. So this is which one? Chiral, and its name is R2-butanamine. This can be resolvable. These are the enantiomers. What do you call these are? enantiomers. Now, the next one is the quaternary amines, quaternary ammonium salts, that is, with asymmetric nitrogen atom can be resolvable. So, which are the resolvable? Chiral carbon amines can be resolvable and quaternary ammonium salts can be resolvable. Reason? This is asymmetric nitrogen, meaning what is a nitrogen with the different group. Ammonium salt means positive charge. It may be any other X minus, whatever that. And here I am using, this is the methyl group, and here ethyl group, here phenyl group. Now here I am using isopropyl group. If it is a R configuration, keep in mind here no lone pair. So why these are resolvable or resolved? Because of no lone pair. Lone pair is there mean it undergo inversion. So lone pair not there, that's why no inversion. Its mirror image is nitrogen on that positive charge and X minus. This is phenyl group, and we can write these are the ethyl group. Next, methyl group, and this is actually isopropyl group in the dotted line. This is dotted line. So these two are enantiomers. So keep in mind, when lone pair is not present on the quaternary ammonium salt, then it is considered as a asymmetric nitrogen atom. There is no inversion. That's why these are resolvable, and these are generally we can consider optically active. Therefore, if it is a R configuration, mean this is the S configuration. But condition one more you have to remember. This is a when we can resolve or not resolved condition. Not resolved condition on nitrogen, on nitrogen atom, lone pair present we cannot resolve, and on nitrogen in case smaller atom hydrogen present cannot resolve. So in this case we cannot resolve, remaining cases we can resolve. And third case, amines that cannot attain the sp2 hybrid transition state for nitrogen inversion. So we can resolve when that amine cannot attain sp2 hybrid transition state. In case in inversion sp2 hybridization if you get, then that meaning what is that? One phase to another phase lone pair will be inverted. That's why we cannot resolve because it falsely interconvert. Therefore, that should not attain this sp2 hybrid transition statement. Generally, it is called no inversion. That's why we can resolve. But condition what is there to resolve this? So based on that, one of the amine that is nitrogen present in a smaller ring. Now this is a three-membered ring, nitrogen in the ring, and this one contain the one lone pair, and on this we have one methyl group. But this should be contain which one? A chiral ring. This is a methyl group, this is a methyl group. Now you observe this is a chiral nitrogen present in the ring. Smaller rings only acceptable. Reason, this should not facilitate the bond angle 120 because in the transition state what will be present? sp2 hybridization will be present. So therefore, if larger ring is there, that easily facilitates to the converting bond angle 120 and inversion takes place. But in case smaller ring with the chiral is there, meaning that we can resolve because bond angle will be the less, because this angle will be the less. Therefore, keep in mind smaller ring with the chiral is there, mean that can be resolvable. Now I am taking this for example R configuration and its name 1, 2, 2, because already in the nomenclature previous video I explained that in heterocyclic compound heteroatom is numbered as a 1. Therefore according to this 1 and this is a 2, this is a 3. So 1, 1, 2, 2 tri methyl and its name called aziridine. Its mirror image, I am drawing now, N, and here lone pair, and this is a methyl group and this is a ring. In this ring we have the two methyl group. This is a chiral and same name with the S configuration. These two are which one? Enantiomers. These enantiomers separate we can resolvable, but in case smaller ring present but not chiral, meaning it cannot be resolvable. So that you have to remember. So generally three membered chiral rings and nitrogen present in the ring that can be resolvable, keep in mind. Now here question, which of the amines listed can be resolved into enantiomer? First, you have to write the structure. What is given here says 2-methyl cyclohexanamine, cyclohexane and amine. Which form this is? Cis form. For example, I am writing front side. This is a NH2. This is a 1 mean. This is a 2. Therefore, this is a cis form. Now 2-methyl. Then this is also chiral carbon and this is also chiral. Two chiral carbons. So first one condition, asymmetric carbon amines are resolvable. Therefore, this can be resolved. It can be possible. Next one, read what they given here: N-methyl, N-ethyl cyclohexanamine. First of all, we have to write cyclohexanamine. Cyclohexane on this nitrogen. One is methyl, another is ethyl. So these are the two, three different groups. Is that mean one lone pair will be present. So in starting we studied that lone pair present meaning it is free to inversion. So due to lone pair, inversion takes place. When inversion takes place, we cannot resolve this. Is cannot be resolved. So this is not answer. Not resolved. Next one, C. What is the C? N-methyl aziridine. First, you write that aziridine structure. This is a nitrogen present in the three-membered ring, and on that nitrogen methyl group will be present, and automatically one lone pair commonly present. But this is not chiral. This is symmetrical. So, due to symmetrical nature, it cannot be resolved. So this is also cannot be resolved. Next, going to for D, ethyl methyl anilinium iodide. Now anilinium meaning what is that? On benzene NH, NH2 mean aniline, but here they given ethyl methyl mean this is a ethyl, this is a methyl, and that much only given mean another must be hydrogen and this will be plus, and iodide means this is a I minus. Now keep in mind this is a chiral ammonium salt, but in this hydrogen smaller group is there, inversion takes place. So due to hydrogen smaller group, inversion takes place. So that you have to remember, or that is called proton exchange also we can consider. What we call this the proton exchange. So due to this proton exchange, we cannot resolve. So not resolved. So this is also not possible. It is actually quaternary ammonium salt, but due to proton exchange, not possible. Next, the last and final one is methyl ethyl propyl isopropyl ammonium iodide. Keep in mind, this is a nitrogen on this methyl is there, ethyl is there, propyl is there, isopropyl is there, and this is a positively charged and this minus. All are different group with the no hydrogen and no lone pair, therefore it can be resolved. So out of A, B, C, D, E, first and last one only resolved, remaining are not resolved. So conditions also I explain why we cannot resolve. Next question is, which of the amine listed can be resolved into enantiomer? Same question, but now what they given? Another some number of example given. In this, the first one, N-ethyl N-methyl aniline. So write first aniline structure. In this aniline, on the benzene N, one has a ethyl group, another one is a methyl group, and aniline, that much only. So this is a chiral phenyl ethyl methyl with a lone pair present. So due to lone pair cannot be resolved, because reason, it undergo inversion. So inversion, that is called nitrogen inversion, therefore not possible. Then B, what is the B? 2 methyl piperidine. 2 methyl piperidine mean what is that? Pyridine structure. In that, pi bonds are not present. So nitrogen atom will get the first number and this will be the second number. At this one, methyl will be there. Then it is also what is a lone pair present. It is not a, what do you call it? Due to lone pair, we cannot resolve mind that will think. But actually, what is present here? Chiral carbon is present. So due to chiral carbon or asymmetric carbon, due to asymmetric carbon, it can resolve. It can be resolved. So keep in mind this can be resolvable. Then C, 1 methyl piperidine. Same structure but small difference. This is methyl group and here lone pair present. So it is called 1 methyl piperidine. So due to symmetrical nature, because it has which one, uh, methyl and left right side equal is there, therefore it is symmetrical. So due to symmetrical nature, we cannot resolved. Therefore, this is not. Then D. What is the D? 1122 trimethyl aziridine. So first you draw the aziridine structure. 1 meaning according to heterocyclic nomenclature we will get this is a 1, this is a 2, this is a 3. On that one methyl group is present. Automatically lone pair present. So 1122. So 2 means this is methyl group. This is also methyl group. So this is asymmetric and a smaller ring. Therefore, we can resolve this. This is resolved with the smaller ring with the asymmetric. Then E. What is the E here? Structure only given. Now this is a methyl group, this is a ethyl group, and this is called symmetrical nature. Don't think this left side methyl, right side ethyl. This is vertically we have to think that is. So it is symmetrical. So symmetrical nature is there, meaning can't be resolved. Otherwise, consider these groups lefts and rights are same is there, cannot be resolved. F is similar to the E type structure, but keep in mind right side what is there, double bond is present. So due to this double bond nature, it become which one, asymmetric. So due to this asymmetric nitrogen with the quaternary ammonium salt, so it can be resolvable because lone pair not there. Another one, no lone pair, and next no proton exchange, therefore resolvable or resolved this is, it is possible. Then what is the next? G. Now you consider this is a smaller ring. This is which one? Smaller ring. But what is present here? Hydrogen is present on this nitrogen, therefore exchange takes place. So hydrogen on nitrogen atom, so hydrogen can exchange here. It is look like asymmetric, this part asymmetric, but due to proton, therefore it cannot be resolvable, cannot be resolved. So it cannot be resolved. The last and final, H. Now you observe here, in on this nitrogen nothing is even, lone pair is present here, and this is a asymmetric nitrogen and with a smaller ring, therefore we can resolve because this lone pair unable to, because this lone pair unable to invert, therefore can be resolved. I, I hope you understood all the this nitrogen inversion and the asymmetric nitrogen atom, and when it is shows the sp2 hybridization, when it shows the sp3 hybridization, and what are the condition to resolve, everything I given. If you have any doubt, you just comment, I will explain.